So let's take a look at number 4 in section 1.3. Here we're given two functions, and yours should be similar to these, maybe not exactly the same, but the function f of x is 1 over x, basically the reciprocal function here, and g of x is x to the negative 3 power. We're going to find f circle g, or f composed with g, right? The composition of f with g, and then we're going to find the composition of g with f. Notice the order matters, so these are different in general. And then also they want us to find the domains for each of these functions, okay? So remember that you need to be familiar with the domains of all the basic functions that we deal with in pre-calculus. This is a list of them. This sheet here can be found in the resources module in Brightspace in the content area. If you go to the resources module, you're welcome to have this and print it out and use it as you're preparing. So be familiar with those domains and ranges. Okay, so first of all, we want to start, since we're going to find the domain and range of these compositions, what's the domain and range of our individual functions? Well, what's the domain of the function f of x? Well, we cannot divide by 0 as that's not a real number. And so the domain for this function is everything except 0, which in interval notation can be written this way. And make sure you read the directions in these problems in the parentheses after the problems. They give you explicit details about how to write these intervals, and they want you to use the interval notation. The domain of the function g of x was x to the negative third power. Remember, x to the negative third power is the same thing as 1 divided by x cubed, right? So you need to be familiar with your rules for exponents. So negative exponents indicate a reciprocal, right? And so x to the negative third power means 1 divided by x cubed. Well, again, this function will be undefined when x cubed is 0, which occurs only when x is 0. So again, the domain for this function is everything except for 0. So let's find f circle g, f composed with g. That is defined to be f of g of x. So we're going to take the output to the function g of x and plug it into the function f. So the function g of x is x to the negative third power. And I'm going to plug that into the function f of x. So I'm going to replace in the function f of x, here's the x. I'm going to replace the x with what? X to the negative third power. So that should be 1 divided by x to the negative third power. Well, what is 1 divided by x to the negative third power? Well, that's just x cubed, right? And it comes directly from this same situation here. If x to the negative n power is 1 over x to the n, then 1 divided by x to the negative n power is x to the n. Okay, again, it's the idea of reciprocal. So again, this would be, you can think of this as 1 over x to the negative n power, which is the same as x over 1 to the positive n power. So you simply can make that exchange. These are equivalent expressions. It's important that you understand these rules of exponents. Now, if I were to just ask you what's the domain of x cubed, you would simply say all real numbers, because I can cube any number and get a real number. However, we've got to remember the domain of the composition function takes into account that we're first going into the inner function g of x, right? And remember, its domain was what? Everything except for 0. So I can't plug 0 into this function, even though 0 cubed is 0. We can't do it because of the composition, right? So we are obtaining this function through a composition. We need to look at the domain of this inner function. We also need to look at the output to g of x and make sure it's in the domain of the function f. The domain of the function f was everything except for 0. Well, can you ever get 0 as an output to the function g? Well, the answer is no. Since I'm dividing into 1, the output will never be equal to 0. Remember, 1 divided by 0 is not 0. 1 divided by 0 is undefined. So the g of x function's range is also all real numbers except for 0. So the bottom line is our domain for f circle G is everything except for 0, which is coming from the fact that we're plugging into the first function G, the inner function G, which has that domain. Similarly, we can do G circle F, that's G of f of x. So G of f of x is 1 over x. So that's 1 over x to the negative third power. So a couple ways you can look at this. Remember, 1 over x is the same thing as x to the negative 1 power, right? And so then I can think of what? When I have an exponent raised to another exponent, what do? We multiply those exponents. So again, rules of exponents you need to be familiar with. I have x to the a and raise that to the b power. That's x to the a times b power. So you need to be familiar with all these rules of exponents. So we get x cubed again, same as the original, same as the composition f circle G. That is not always the case. Okay, when you do f circle G, G circle F, most of the time you're going to get different results. Okay, domain here again, well, same thing. We start with f of x, which is 1 over x. Its domain is everything except for 0. And I will never output 0 when I divide into 1. And so we're good for the function G, provided x is not 0. And so therefore, that's the domain for G circle F. Okay. All right. I hope that this makes sense.